passports, didn't really understand smart card technology and tried to just plug all the things that they had readable for humans and readable for machines into the remote readable or RF readable stuff with all the security risks and break-ins that it involved. For EMV, the banks, the main reason to use cards is that they want to verify pins at the point of sale or the point of service, and security is very important there. But in GSM, security was nice, but the reason they wanted it is that smart cards enable operators to work on handsets that are manufactured by independent companies, and they share the customer in a way. So this concludes my introduction to smart cards, and we can now move on to Java card and see what is special there. The reason we started Java card was to make it easy to write code for processors that run on smart cards. At that time when we started, which is in '96, there was no way of programming cards except writing assembly, and some C compilers were emerging, but you basically wrote assembly code and had to handcraft everything you did. And every application required a new mask, and masking time was 20 months or so to get a new version of the software in the smart card and test it. So having software that could be loaded in non-volatile memory and programmed and tested as you write normal code and using object-oriented languages to express the things you want was why we started Java card. We also want to make sure that if you have one application on the card that works with some keys and some data, it is separated from anything else on the card, and that's the multi-application card. There are only a few of them still exist, but that was the intention when we started. And of course, since you write in a high-level language, you can actually communicate with the card in basically the same way you communicate with any other processor, and that also would make it easier to use smart cards. Let me see where we are. So Java card starts with Java programs. And you compile a Java program. The animation should work. The Java you use is not the full Java. It is a subset. And I will talk about the things that are not in Java later. The compiler is just a standard compiler. And the class file is a standard class file. But of course, since you don't use all the, since you cannot use all the bytecodes because some things won't be accepted by the card, and therefore, in general, because you programmed correctly, you will have only a subset of the bytecodes in your class file. Then you take the class file, and it is processed in your development environment in something that's called a converter nowadays. This slide, by the way, I found in the presentation I gave in 2000 for the NSA, when we tried to convince them that Java card was good for the military identity card. So I thought this was a proper occasion to show it again. The post-processor, the converter, takes the cap file, more cap files for all the classes you have made, and class files and creates them into a cap file, which is a loadable file that can actually be loaded into the card. And in the card, you'll find a library of classes which are specified also as Java language, but they're implemented in the card as a reference. And then you have the virtual machine, which is not a Java virtual machine, but it's a virtual machine that looks like Java virtual machine, and it is programmable through this whole path in Java language. The result is an API, a virtual machine, and some hardware facilities underneath it. Just another layered software architecture. The applets can be anything. They are separated. Usually you'll find an applet that is the manager applet that allows you to load code and that can install and manage the keys in other applets. So what is special for Java? The objects are very simple. There's no clone, there's no hash code, there's equals you can implement if you want. There is no system. There's a special GC system class which has some facilities that Java system class will bring. What is new, it has transactions. Every modification to an object that's stored in a non-volatile memory is always transacted, so you will always be sure that what you want to write is always written, and the VM only resumes when things are written. There's a special facility for creating larger combinations of writes into a persistent transaction, which has a rollback facility, and you can actually explicitly remove a change to your data by rolling back changes. And then there's the firewall, the separation between applications. This is not the same thing as the sandbox or model of security. It is a really virtual VM. When you are an application Java card, each application runs in its own virtual VM, although they share the heap and they share the stacks and all the things are basically separate when you are running in the firewall. There are ways to communicate through the firewall, but it's too complicated to go into right now. But you can exchange data between applications in different firewalls. So there's no longs, no floats, no doubles, no ints, no strings, no char, and there's no multidimensional arrays. It's pretty limited. The limitations came from the small size that we needed at the time. And still, if you look at RFID chips, they are still small, and Java card is still very suitable for very small processors. There is a special runtime environment which has no garbage collection, no threads, no cloning, no dynamic class loading. All the class loading is done before you even load into the card in the converter, in the post-processor that takes all the class files and basically does all the loading and all the linking that happens beforehand. This technology goes back, way back, almost as old as the previous speaker about IBM. 1994 was the first version of the Java card technology. In 96, Schlumberger Technologies in Austin released a spec called Java card, but that didn't go anywhere. It had a brand name Java card, it had programmable in Java, but the runtime model was completely wrong. And the redone version, the second version in 97, was the one that was taken up in the market. In GSM started doing it in 99, and in the end of 97, Sun Microsystems actually bought the company that I worked for, and Java card has been with Sun ever since. And last year, the third version has been released. We have only seen 3 changes in the specs, very minor changes. And in 2008, a third version was released. Much larger footprint for much larger chips. It can connect, it can support an IP stack and all kind of other things that servers support. But as up to now, only very few companies have actually taken up. And the old specification will live on as a Java card classic or whatever brand Sun will stick onto it, but it will stay on and it'll be available for use. An application in Java card is built like any other application. You design code and debug and make sure it runs. Then you have to go through the converter. There are all kinds of end tasks that will integrate all this work for you. And then you have to go and find a card or find an emulator and load it on and make sure it actually works on the card. If you buy an IDE from a smart card vendor, you will get a set of blank cards which are open, and you can actually load them as if you are loading in a real card, except there's no protection on that load mechanism, so the cards are really open. That would be the only way to actually get real cards that you can actually read a program in Java card is to buy a development kit from a vendor. So finally we can show some real Java code. So those who have been waiting for real Java,